So let's look at an example. At a large public state college in Virginia, the mean verbal SAT score of all attending students was mu equals 600 with a population standard deviation sigma equals 65. If a random sample of 100 students is selected from the population, determine A, the probability that the mean verbal SAT score of the selected sample will be less than 615. B, the probability that the mean verbal SAT score of the selected sample will be within 10 points of the population mean. Okay, so if we look at the numbers that were provided to us in this problem, n is greater than 30. N is 100, which is greater than 30, and therefore the central limit theorem says that the sampling distribution of means can be approximated by a normal distribution. So with just that knowledge alone, we know we have the ability to use normal CDF to answer this probability question. To use normal CDF when dealing with the sampling distribution, you need to know the mean of the sampling distribution and the standard error of the sampling distribution. You cannot do normal CDF unless you know those two values. So at the end of the last lecture, we had quite a few examples where we figured out what the mean and standard error of the sampling distribution was. We have to remember that the mean of the sampling distribution, mu x bar, the mean of all the sample means, is always equal to the population mean mu. So in this problem, the population mean mu is 600, so mu sub x bar, the mean of all the sample means, is 600. That becomes the third input into your calculator. That's the input for the center of the distribution. The standard error, we are going to use the formula sigma divided by the square root of n. So the standard error, sigma subscript x bar, which is basically the standard deviation of all the sample means, is the population standard deviation divided by the square root of the sample size. So from last lecture, we did this on our calculator, and you could figure it out too. If you look at sigma, it's 65. Sample size is 100. So you're going to take 65 divided by the square root of 100, and that should give you 6.5. Okay, so little to no work in defining the mean of the sampling distribution, a little bit of calculation to find the standard error, and now we're ready to use normal CDF. Okay, normal CDF requires 4 inputs, and these are the last two. This is input 3 and input 4. Okay, so part A asks us to find the probability that the mean verbal SAT score of the selected sample will be less than 615. And this is where questions from this chapter are going to differ from questions from Chapter 7. In Chapter 7, you may see a question that asked, find the probability that a student's verbal SAT score is less than 615. In Chapter 8, we're finding the probability that the mean verbal SAT score for the selected sample of those 100 students is less than 615. And that's the difference between Chapter 7 and Chapter 8. Recognizing that difference is really half the battle here. When you recognize that difference, the problems generally are very, very similar. Okay, we're going to look at our normal curve, and in the center we're going to label the mean of the sampling distribution and the standard error of the sampling distribution. 600 and 6.5. Now this bell curve doesn't represent the population, it represents the sampling distribution. Remember that a sampling distribution is a collection of all possible sample means, in this case sample means of size 100, because our sample had size 100. So this bell curve represents 100% all possible samples of size 100, all the possible sample means of size 100. So we have sample means on this part of the horizontal axis. These values for x bar sample means are small. Then they get larger. In the center, these possible sample means are close to 600, and then the sample means get larger and larger, and these are the largest possible sample means. And we discovered from last lecture that sample means can range. They can have a range that goes from a small value to a large value, and that collection, all 100% of them, are represented by this bell curve. The x bar that we're interested in is 615. So if we look at the wording of part A, it says find the probability that the mean of the sample is x bar, and you want that mean of the sample to be less than 615. So we simply find 615, label it on the horizontal axis. This is the location of this value for x bar, and shade in all the values to the left of 615, because it says less than 615, so we're going to shade the proportion of area to the left of 615. When we find this proportion of area, we'll be answering the question of the probability that the sample mean is less than 615. That's what this area represents. It represents a probability. So we're going to go to our calculator into normal CDF, and the four values that we're going to put in are a low value, which is way on this side of the bell curve, an upper value, which represents the upper sample mean, 615, a mean, and a standard error. Not a standard deviation, but a standard error. Now that's why we calculated sigma x bar earlier. So we're going to put a lower of negative 100,000, an upper of 615. The mean of the sampling distribution is 600, the same as the mean of the population, and the standard error of the sampling distribution is 6.5. So I'll do this with you on the calculator to demonstrate how it's done. So you're going to use normal CDF just like you would in Chapter 7. The lower is negative 100,000. The upper is 615, that upper sample mean. The mean of the sampling distribution is, 600, and the standard error is 6.5. Oops, 6.5. Paste it. Okay, hit enter. 0.9895 when rounded to 4 places. So going back to the PowerPoint, 0.9895. So if we were to put this into words, we can say that the probability that the mean verbal SAT score of the selected sample will be less than 615 is 0.9895, or 98.95%. Part B of the question asks us to find the probability that the mean verbal SAT score of the selected sample will be within 10 points of the population mean. So let's understand what within 10 points means. The population mean was 600. Within 10 points of 600 means everything from 600 minus 10 to 600 plus 10. Okay, so that means everything from 590 to 610. The sample means which are 10 points away are a sample mean x bar of 590 all the way to a sample mean x bar of 610. So let's make a picture. We have to find the probability that the mean verbal SAT score of the selected sample will be within 10 points of the mean. That's the same thing as asking what's the probability that the mean verbal SAT score is between 590 and 610. Okay, so notice that it's not asking find the probability that a student's verbal SAT score is between 590 and 610. it's asking, find the probability that a mean of 100 students have a verbal SAT score mean that is between 590 and 610. Again, that's what makes this chapter different from the previous chapter, and that's why you have to use the standard error in using normal CDF. So we've got the center is labeled at mu sub x bar and sigma x bar because, again, this bell curve doesn't represent a population. It represents a sampling distribution of means. 600 and 6.5 are the values. On the low end, on the left-hand side, we have a sample mean of 590. On the right side, we have a sample mean of 610. So here's 600, we minus 10, we get 590, we add 10, we get 610, and the probability that we have a sample mean that's somewhere between 590 and 610 is represented by all this area in between those two numbers. Okay, so the x bar, the two values for x bar that we've labeled are 590 and 610. So this is a problem that's not going to negative infinity or positive infinity. It's staying between two finite values of x bar. So on our calculator, our lower value is a sample mean of, oops, this is a problem. It should say 590. I'll correct that. An upper value of 610, a mean of 600, a standard deviation or standard error of 6.5. So let's go to our calculator. 590, 610, 600, and 6.5. So to find probability, we use normal CDF. We're going from 590 to 610, sample mean of 610. 600 is the mean of the sampling distribution. I know the calculator is not going to use different notation. It's just going to use the same notation as we had in Chapter 7. It's your job to understand that this refers to the center of the sampling distribution, and the sigma, even though it doesn't say sigma x bar, it represents the standard error. Paste, and this will give us 0.8761. It'll give us the proportion of area between 590 and 610. Okay, 0.8761.